All right. Calculus AB, Unit 4, Day 1. So, um, here's the fun part. This is sort of like our first calculus unit. I mean, I've given you guys some calculus here and there, but it's official. So, we're going to be talking about limits, which are the foundation of calculus, and we're going to have to use them to figure a lot of different things out. So we're gonna make sure we understand limits really well. So as a silly example, let's say you're trying to figure out what your curfew is. You know, when you're supposed to be home. Your mom says 11, and then of course you go and you ask your dad, so you can get a better answer, and he says 12, and you're thinking, oh, that's awesome. But you just come home at 1 and say, well, since you guys didn't agree, then there was no curfew, right? So this idea, when limits from each side don't agree, there is no limit. Now, I don't know if I would recommend you using this as an excuse. Even if they can appreciate the logic, I don't know if they'll appreciate it in general. But I think I had one student tell me they tried this and it didn't work out. Uh, it didn't really help. But we talked about Zenos Paradox back, I think maybe on day 1 or day 2 of this year. And this idea that you can come, but you can't, you can never leave the classroom because you always got to go half the distance of what's left. Half the distance, half of what's there would be another fourth, half of what's there. And like you always have half of what's left to go, so you're never going to get there. Now, here's sort of another way of writing that. It's like half, and then half of half, and then half of a quarter, and then half of an eighth, and half, and it keeps going. And, does it ever get to 1? So some say 1, some say like almost 1, but I mean, if we think about this in reality, you do get to the door, don't you? I mean, you're going to get there. So the way we write limits, and this is sort of a general way of writing it, limit as x with the arrow to a of some function, and gives you some answer. So this is just sort of generally how it's written, generically. Now, the way we read this is we say, as x approaches a, so as it gets close to a, approaches a, then f of x approaches L. So this is kind of a way to think about it, right? As x gets really close to A, f is getting really close to L. And f is like the y value of a graph, okay? Now, here's the deal. As x approaches A, this is a two-sided issue, okay? So we got to approach A from both sides to determine our answer, okay? This is like the y value. So we're going to be looking at those starting today. There are many different ways that we can determine a limit, and I'll just mention them all, but today we're going to really be sticking with the graphical. Graphical is looking at a picture. And I would say that looking at a graph of a function, you can kind of tell what's going on. You can tell a lot of things that we've had to determine. And so we're going to start with that, which kind of gives you, I think, also a really good understanding of the idea, so that when you don't have a picture, at least you can kind of imagine what's going on. Algebraically, which will probably be the one that we use the most, and we will focus a lot on, we could use a table on our graphing calculator and enter just different numbers getting closer and closer to a certain value and see what happens with the y's. And so just, those are the different approaches. This is sort of just a quick, interesting example. And so what we usually do first is we just plug the number in wherever we see x's. That's called substitution. And sometimes that gives you an answer, but it's a pretty boring problem. So usually we're going to get ones, like if you plug 4 in here, 4 minus 4 is 0. Square root of 4 is 2 minus 2 is 0. Now, what is it? Is it 0? Is it undefined? Because if you divide by 0, it blows up, right? But if 0 divided by anything is 0. And so, in fact, you can't tell. It might actually be 3 or something. So we call this an indeterminate form because you cannot determine the answer from it. And so we'll have to figure out how to do that, how to figure out what it is. There are other indeterminate forms that we will encounter this chapter. One of them is going to be infinity over infinity. Okay. But there's even others like, now you might think, oh, well, doesn't that equal 1? Maybe. Probably not. How about 1 to the infinity? Oh, that just equals 1, right? Not quite. Not necessarily, right? How about 0 to the infinity? Well, wouldn't that just be 0? Maybe not. Now, these are some that I'm going to show you guys in Calc BC, but this is one that you're going to be doing. This is one we're going to be seeing a lot. Now, this would probably be a hard function to try and graph, so we don't want to have to rely on the graph to get the answer, and so we would need some kind of algebraic approach. And so in this case right here, what we could do is we could, factor the top and bottom and see if there's anything that we can do to simplify it. Now you might think the top and the bottom are prime, already factored, but look at the bottom and think, okay, could I get a square root of x minus 2 out of this? You could actually think of this as a difference of squares. You might, oh, but x isn't squared, but square root of x squared would give you x, right? 2 squared would give you 4. So it could be square root of x minus 2, square root of x plus 2 over square root of x minus 2. Like, we could do that. And then we could say, well, let's cancel those out and take the limit of what's left. And we're going to try and plug 4 in again. Square root of 4 is 2 plus 2 is 4. And the answer is 4. And that is the answer, by the way. Now, maybe you should feel uneasy about this, but why can we just cancel those terms out? And the reason is that there's actually a hole in the graph right there. And the graph actually does really behave like this graph, but there's a hole in it right at x equals 4. It's kind of weird. But you don't even know that yet. We'll talk more about it later. Okay. And if you took pre-calc, then you may have, done some of these limit stuff. You might have studied rational functions and functions that have holes in them. If not, I will show you what you missed. Now, here are some graphical problems that will be similar to today's assignment. And these are generally pretty quick and easy. So there's, a lot of times piecewise functions that are kind of interesting. Now, you'll look at these. It says the limit as x approaches 3 with the a superscript -1. Now that doesn't mean -3. That's telling you this is a one-sided limit from the left side, from the negative side. Okay, so these two right here, these are called one-sided limits. Even though limits are two-sided issues, we can kind of specially just look at one side.